Hello dear students, I welcome you all in today's lecture of managerial economics. As you know that in the last lecture we have studied about the optimization techniques. We have discussed about the multivariate optimization. The multivariate optimization is the case where a business firm have more than two variables and the business firm is solely interested to maximize his profit or to minimize its cost. In today's lecture, we are going to cover the topic of constraint optimization. As we know that many times the business firm is facing some constraints. So, in the presence of constraints, how the business firm can get maximum profit or how the business firm can minimize its cost. So, constraint optimization topic will cover such kind of constraint the business firm faces in daily practices. Before this topic, as we have discussed about optimization with calculus, about multivariate optimization, in those cases we have no constraint. So, that kind of analysis is also known as unconstrained optimization. So, unconstrained optimization refers the maximization or minimization of an objective function subject to no constraint. But most of the time, however, managers face constraints in their optimization decisions. For example, a firm may face a limitation on its production capacity or on the availability of skilled personnel and crucial raw materials. As we know that in most cases the business firm faces many constraints. The business firm wants to hire more skilled personnel, but it is unable to hire more skilled personnel. Similarly, the business firm wants to get more crucial raw materials, but every time the business firm cannot get the required raw materials. Besides, firm may also face legal and environmental constraints. It means that from the government side, they are also facing some constraints. The government decides that the business firm will not produce their quantity beyond this level. It means that the government restricts the level of output. Besides, we also know that when the business firm is working to produce some output, they are also producing pollution. So, it is a threat to environmental degradation. It means that for the environmental security, carbon dioxide emissions, they are a problem. Carbon dioxide emissions, huge carbon dioxide emissions is a problem for the environmental security. That's why the government is levying carbon tax on the business firm. So, from the discussion we can conclude that the business firm is not always free to take their decisions regarding the level of output. It means that in the presence of constraints the business firm faces, we have the constraint optimization problem. It means that the maximizing or minimizing of an objective function subject to some constraints. So, the business firm will keep these constraints in order to maximize its profits, in order to find out their optimal output level. So, these constraints are always there. In this topic, we will cover that if the business firm is having constraints, so how the business firm can maximize its profit or how the business firm can minimize its cost. So, constraint optimization will cover two main points. First, objective function of the business firm. And second one is constraint function. Objective function of the business firm. As we know that the basic objective of a business firm is to get maximum profit or minimum cost. This is the basic objective of a business firm, either to earn maximum profit or to produce their output at the minimum lowest possible cost. So, in this case, the business firm tries to maximize its profit subject to some constraints it faces. The constraint may be legal constraints, the constraints may be environmental, the constraint may be physical, the constraints may be financial. So, the basic objective of the business firm is to maximize its profit subject to the constraints it faces. In the presence of the availability of constraints, the producer is not having free choice to produce as many units of output as it wants. It means that constraints will restrict their decision, their output level regarding how much to produce during a given period of time. So, the existence of such constraints reduces the freedom of action of the business firm and usually prevents attainment of its unconstrained optimum. It means that in the presence of constraints, the business firm restricts its choice regarding the level of output. As we know that if there is no constraint, the business firm is having no constraint, then the business firm can produce as much units of output as it wants. But in the presence of constraints, the business firm restricts its choice regarding the level of output. It means that the business firm cannot produce as many units of a particular output as it wants. Without the presence of constraints, the producer can increase the units of output to as much he wants. But in the presence of constraints, this output level is restricted. It is restricted. It doesn't mean that he can produce as many units of one as it wants, as he desires. But in the presence of constraints, he is not able to achieve that level it desires. He will restrict his choices up to the level where he can produce. So, in the constraint optimization, we are talking about the objective function of the business firm and along with the constraint function, that how in the presence of constraint the business firm can increase its profits or minimize its cost. So, constraint optimization problem can be solved by two methods. We have two methods to solve the constraint optimization problems. The first method is known as the substitution method, and the second is known as the Lagrangian multiplier method. There are two methods. Use to solve the constraint optimization problem. The first one is the substitution method. The second one is the Lagrangian multiplier method, or shortly we can say the Lagrangian method. These are the two methods which we can use to solve the constraint optimization problem. Let me first start with the substitution method. How we can use the substitution method in order to solve the constraint optimization problem. The substitution method. So, constraint optimization by substitution. A constraint optimization problem may be solved by first solving the constraint equation. As we have discussed that in this case we will be having two equations. The first equation is known as the objective function of the business firm, and the second equation or second function is known as the constraint function. So, by using this method, what we will do? In the substitution method, a constraint optimization problem may be solved by first solving the constraint equation for one of the decision variables. We have two variables, as we have discussed that previously. We have discussed that profit is the function of x and y. X means commodity x, y means commodity y. So, these are the decision variables. These are the decision variables. So, a constraint optimization problem may be solved by first solving the constraint function, the constraint equation for one of the decision variable, and then substituting the expression for this variable into the objective function that the firm seeks to maximize or minimize. For example, we have the profit function. This is the original objective function, and here we have a constraint. For example, x plus y is equal to some value. This is known as the constraint function. So, in this substitution method, first we will solve one of the decision variable from the constraint function. Either we can solve it for x or we can solve it for y. So, first we will solve one of the decision variable from the constraint function. After that, we will substitute that function into the original objective function that the business firm wants to maximize or minimize. After that, we can solve for the second decision variable. Let me give you a specific example. This procedure converts a constraint optimization problem into an unconstrained optimization one. So first we have a constraint optimization problem, but with the use of the substitution method, we can get the unconstrained optimization function from the constrained one. Then we can solve it for x and y, which are known as the decision variables. For example, we have the objective function profit x, y. These are the decision variables. Profit is equal to ATX minus 2x square minus xy minus 3y square plus 100y. This is known as equation 1. This is the original objective function of the business firm. The original objective function. This is the original objective function which the firm wants to maximize. Look at the case here. We have the symbol of profit. So the firm always wants to maximize its profit. So maximization of the profit is the sole objective of the business firm in this case. So how the business firm can get maximum profit? By producing an optimal level of x and y in the presence of constraints. So this was the original objective function of the business firm. Let me write the constraint function. X plus y is equal to 12. This is known as the constraint function. This is the constraint function. Let me call it equation 2. This is equation 2. What does it mean? It means that the business firm combinedly produces both the commodities, yani x and y, 12 units. Means the number of units of x and y must not exceed 12. So both the producing commodities must equal to 12. This is the constraint, that he is not able to produce commodities more than 12. That's why we call it constraint function. So the question is that how the business firm will maximize its profit subject to the constraint function it faces. So in this case we are using the substitution method. For the substitution method, we will solve this constraint function in terms of any of the decision variables x and y. We have two decision variables. Commodity x is the first decision variable and commodity y is the second decision variable. We can solve this constraint function in terms of any of the two decision variables. Then we will substitute that expression in the original objective function to make it unconstrained. So let me solve. To solve this optimization problem by the substitution method, that how we will solve this problem. So with the help of the substitution method, we can solve the constraint optimization function for x. Suppose I am going to solve the constraint optimization problem for x decision variable. Then we will substitute the value of that x variable into the original function that the firm seeks to maximize, means the profit function, and then apply the procedure for maximizing an unconstrained objective function. So, as we know that x plus y is equal to 12, this is the original constraint function. Let me solve this equation for x. We can write it as x is equal to 12 minus y. Let me call it equation 3. This is the equation 3 which I have solved for the commodity x, which is one of the decision variable. So, let me substitute this value of x, this expression of x into the original objective function, which is known as the profit function. So, this was the original function, that profit is equal to 80x minus 2x square, 80x minus 2x square minus xy minus 3y square plus 100y. This was the original objective function of the business firm, which we are denoting from the equation 1. This was the original equation 1, and this was the constraint function equation 2, and from the constraint function we have derived x, which is equal to 12 minus 5. This is equation 3rd. Now, substituting equation 3 in this profit function. Substituting equation 3 in equation 1. This is the original equation 1. So, we can write it as profit is equal to 80x. So, for x we will substitute this value 12 minus y minus 2 x square, x 12 minus y whole square minus x 12 minus y into y minus 3 y square plus 100y. Multiply 80 with this expression. So, 80 multiply 12, we can get 960 minus 80y minus 2. Now, 12 minus y square, 12 minus y whole square. How to solve this? We can solve this by using a minus b whole square formula. So, we can write it a square minus 2ab plus b square. So, this is a, y, this is b. Substitute. So, we can write it as 12 minus y whole square, a square, 12 square 144 minus 2 into a, 12 into b, y plus b square, y square. We can write as 144 minus 24y plus y square, or we can also write it as y square minus 24y plus 144. So for 12 minus y whole square we can substitute y square minus 24y plus 144 minus 12 minus y multiply y minus 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 plus 12 y plus y square minus 3y square plus 100y. Now we can multiply 2 with this expression, and after solving we can write the final expression as profit is equal to minus 4y square plus 56y plus 672. This is the final expression after solving this equation. Let me denote it with equation 4. This is known as equation 4. Now this is the unconstrained profit function. The first was constrained, now this is known as the unconstrained profit equation or profit function. This is the unconstrained profit function. Now it is simple to derive the value of x and the value of y. So the final unconstrained equation is, let me write it again, profit is equal to minus 4y square plus 56y plus 56y plus 672, equation 4, which is known as the unconstrained profit function. So we will take first derivative of this equation with respect to y, and we will set that expression equal to 0. To solve for y, we can get y from here. So taking first derivative, we will take first derivative of this expression, I mean this profit function with respect to y, and we will set equal to 0. From here we can find out the value of y. How? Let me solve it. Taking derivative of this profit function with respect to y, change in profit due to change in y with respect to y, minus 8y plus 56, this is constant which is equal to 0, minus 8y plus 56 is equal to 0. Solve it for y. This implies that minus 8y is equal to minus 56. Minus minus cancel out. So 8y is equal to 56. Dividing both sides by 8. 56 divided by 8. 1, this is 7. So it means that y is equal to 7. This is the value of the first decision variable. So if the business firm produces 7 units of y, so the question is that how much units of x the firm should produce in order to get maximum profit. X is unknown in this case. So for the X, we will substitute this value of Y in the constraint function. We can get the value of X. The function was X is equal to 12 minus Y. This was the function. Now substitute 7 in place of Y in this equation. X is equal to 12 minus 7. We can get 5. So X is 5. It means that the firm maximizes its total profit when it produces 5 units of X and 7 units of commodity Y. So how much profit the business firm will earn? For finding the profit level of the business firm, substitute X equals to 5 and Y equals to 7 in the original profit function. We can get the profit function. The original profit function was pi equals to 80x minus 2x square minus xy minus 3y square plus 100y plus 100y. This is the original objective function of the business firm. As we know that x is equal to 5 and y is equal to 7, substitute the value of x as 5 and the value of y as 7 in this original function, we can get profit. So let me substitute. Profit is equal to 80x, x is 5, 80 multiply 5 minus 2 x square, 5 square minus x, 5y, 7 minus 3y square, 3, 7 square plus 100y, 7. After solving this equation, we can write the total profit of the business firm is $868. This is the total profit of the business firm. So this was the substitution method. In the substitution method, first we will solve the constraint equation in terms of any of the decision variables. Then we will substitute that equation in the original profit function or the original objective function. So the original objective function will become an unconstrained optimization equation, that will become an unconstrained function. After that, we will take the derivative of that unconstrained profit function with respect to suppose y and will set equal to 0. From there we can get the y value, which is 7. After getting this value, we will substitute this value in the original original constraint function in order to find out the value of x. After finding the value of x and y, we will substitute both values in the original profit function in order to find out the total profit of the business firm. So this was the substitution method. Let me solve the constraint optimization problem with the help of Lagrangian multiplier method. Constraint optimization by the Lagrangian multiplier method. This is the second method which we often use to solve the constraint optimization problem. When the constraint equation is too complex, for example, in the last case we had the constraint equation was x plus y equals 12. This was the constraint equation. So, if the constraint equation is too complex or cannot be solved for one of the decision variable, if this is, for example, if this expression is too complex to solve, or it is impossible to solve this constraint function in terms of any of the decision variable for x or for y, in that case we will use the Lagrangian multiplier method. So, when the constraint equation is too complex, or cannot be solved for one of the decision variables as an explicit function of the other, the technique of substitution to solve a constraint optimization problem can become burdensome or even impossible. In such cases, we may resort to the Lagrangian multiplier method. So, it means that if we have two cases, the first case is the constraint optimization function is too complex to solve it for one of the decision variable. So, in that case we will replace the substitution method by the Lagrangian multiplier method. So, in the first stage we will form the Lagrangian multiplier function. We need to write for the Lagrangian function. So, in the first step in this method is to form a Lagrangian function. This is given by the original objective function that the form seeks to maximize or minimize plus lambda times the constraint function. So, the first step is we need Lagrangian function. The question is how to form a Lagrangian function. We denote it with the symbol L. For example, we can write it as Lagrangian function. So, it will be like this: objective function plus lambda multiply constraint function. We will write the objective function of the business form plus lambda times constraint function. By this way we can form the Lagrangian function, and then we will set equal to 0. We will set this function equal to 0. This is known as the Lagrangian function. The Lagrangian function can be treated as an unconstrained optimization problem, and its solution will be identical to the original constraint optimization problem. So, this was the first. Then we will set the constraint equation equal to 0. In the second case, constraint function or equation equal to 0. After that we can solve the Lagrangian function in order to get the maximum profit level of the business firm. So, in the next lecture I will show you how to write a Lagrangian function and how to solve a Lagrangian function in order to get the maximum profit of the business firm. That's all for today. See you in the next lecture. Thank you so much.